Alright, hopefully this is no surprise to anyone, but we're doing binary search trees today. Oh look, part 1. That's because tomorrow will be, our next class will be part 2. Let's see, begin construction of binary trees. Very important to get these down before proceeding to further functionality of any trees, not just binary trees, but other ones as well. Please implement empty constructor, copy constructor, put in order string, and lowest common ancestor, and a deconstructor. All right, you can make a binary tree. Hey, look, we made one in class. You can fill in the private parts or private member variables. Whew. I started a print, a recursive print, and a recursive in order string. If you want to use it, you don't have to. It's up to you. Create an empty binary tree, create a binary tree from another binary tree. Now, that one's going to be tricky because when you make a second binary tree, it needs to be
in the same order.
In the same order. So that one's going to take a little while. But hopefully you can see how to do it, yeah, well.
So that's basically the opposite of the post order, because you're printing from the top down then?
Actually, wouldn't it be pre-order?
Yeah.
Yeah, so then you add the 5, the 2, the negative 30, then 3. So as long as you traversed in pre-order, adding in pre-order, then it'll work. There, gave you a use for pre-order. All right, do not do any balancing. Okay, I did not talk about balancing. I'm going to show you what not to do, even though I know that's dangerous. Notice the problem here is that we have a -3 right here. And so, but the level before it is empty. Balancing would be rearranging the binary search tree so that only the last level has empty nodes in it. Okay? Don't do that for this exercise. You will fail the test cases. It's a lot harder to balance than to not to balance. So if any of y'all go crazy and decide to start balancing, don't. That's project 3, by the way. Balanced binary trees. So don't do it. Huh?
Getting ahead of the game.
I'm just, fair warning, get your mind started on things. Height, return the height of the binary tree. I talked about what height is. Well, now we've gone through 2 different ways to go through a tree, so hopefully you can come up with an idea. So in order string, okay. This one sometimes gets students a little confused, and most of the time, by the way, you need to get this function implemented, or a lot of the test cases you're going to just start failing, because this is how I'm going to test your binary search tree, or one of the ways, I should say. Wow, again, the formatting's terrible. Anyways, if you have let's see, a tree, it's 4, then 1, and then 10. It needs to print off 1 space 4 space 10 space. I'm just doing that to make it easy for y'all, so you always, when you're at a node, print the number and then a space afterwards. Some people want to trim that last space off. You will fail the autograder if you do that. Yes. All right, lowest common ancestor. For some reason, this one never prints out correctly, so let's see if I can look at it here. Here we go. So here we have a tree, 4, 2, and 8, and 1, 3, 6, and 10. So the lowest common ancestor of 1 and 3, aka here's the 1, here's the 3, is the 2. 4 is also an ancestor, but it's not the lowest. For 1 and 2, the answer is 2, because you can be an ancestor of yourself. 1 and 6, well, you have to go all the way up to the top of the tree to the 4 in order to get it. Obviously, I'm going to give you a bigger tree for some of these tests. But y'all see what the ancestor is? It's basically the first node that you can branch off of and get to the other ones. All right. Recursion is going to be really helpful for this lab. This is really where recursion is going to start making everything nice for you. And don't forget to free your memory. All right. Let's see, memory management, due a week from today. Don't forget to run Valgrind, and I highly suggest running test cases. Any questions? Comments? Screams? All right. So that is all for today. We finished, looks like 10 minutes early. Perfect. I will be here